What's going on here is that Cambered-Effect means that when the air being drawn into the low pressure zone generated by the whirling fan blades, that air tries to follow the curvature around the cylindrical flue, and it goes following that metal until it breaks away, and it breaks away on one side or the other. And when it breaks away on one side, it means you get a fast airflow through the other side. And that's why the airflow through the disc is alternating from one side to the other. And sometimes the high speed air comes around this side and goes through the disc, and other times the high speed air goes around the other side of the flue and goes through the other side of the disc. So you get this alternating plaited smoke trail effect. And the smoke is only showing whither goes the airflow. Back and forth and left and right. This is why industrial chimneys are often equipped with sheet metal spiral strips poking out perpendicularly from the vertical flue, running at 45 degrees to everything up the top half of the chimney. It means that you don't get the airflow being left to its own devices and choosing to stall alternately on the left side and then the right side, and then the left side and then the right side, and then the left side and then the right side. Because if that were to happen, oh, that's a bit better. Sorry about the biological organic lens hood. If you let it do that, then you're still in a situation where thrust equals drag, and the thrust is the engineering strength of the flue resisting the drag of the wind. And if you've got an airflow following first one side of your chimney and then the other side of the chimney, it's going to generate lift off one side first, and then when that stalls, it'll generate lift off the other side. And that alternating flow, caused by random surface irregularities versus Cambered-Effect, that's going to cause an alternating wig-wagging wobbling stress that eventually breaks the chimney. It's not going to break anything here, but it means that this particular fan with its particular design has a particularly difficult time in generating a smooth laminar flow. Part of the issue is that, as you can see, the part of the fan that's working the hardest is on what you'd have to call the inner 1/3 of the disc. The smoke's not coming through the outer half at all, not much between the halfway mark and the 1/3 mark. It's all going through there, and then in the middle of that there's the motor, which blocks that flow. So you get this conical area of low pressure zone downwind of the motor, which sucks smoke into that. And then the smoke trail basically is produced by a little donut. Here we go, try this one instead. Can you see that little strainer of smoke coming off the incense stick? See how the incense stick is slightly behind the plane of rotation, which I've thoughtfully marked. Now, look at that. Here we see incense smoke being drawn in from behind the plane of rotation. There we see the white tips marking the line of the plane of rotation. Here we have an incense plume. We're coming in here, and this incense plume it's going through there. Now it starts really getting drawn in. Look at that. Smoke trail going backwards through the tip. And that's your forward direction. Got a pretty fearsome airflow here. That's your forward direction. And look at that. That's the boundary of where the air's going backwards through the tips and forwards through the central disc. And then there's a very slow, spirally, wiffly wobbly airflow being knocked around by that spiral. Isn't that lovely? Corkscrew in the middle. And from the corkscrew, we come out, we're in the turbulent zone, and yeah, now the air is going back through the tips, because pressed sheet metal propellers, and this is the best they've come up with yet, you know, this is the 4th generation, this is the $143 in the hardware shop. Latest, greatest runs down to 58 degrees Celsius type Peltier-Effect cooling fan, thermatic fan, stovetop fan. Yeah, really strong airflow, sucking like buggery in there, right in at the centre. Come up here, yeah, not so much. Around here, quite a lot of airflow, because that's where the fan is sucking through the constriction, drawing air over the sheet metal, and Cambered-Effect is meaning it's sucking air around there. And one more interesting kind of a demonstration. Here we have the infrared laser dot thermometer, 31 degrees, 28, 30 on the floor, 28 on the wall, 30 on the front of the glass, 135, 380, 412, 230, 250, What's that? Oops, I thought I was showing you where I was looking at. 140, 250, 220, 440, 94, 220. Okay, up here, 78 degrees, 83 degrees, 96 degrees, 97 degrees. Oopsie, show it to you where I'm looking at. Down there, below the Peltier device, 131. Above the Peltier device, about 100. Up on top of the heatsink, 75, 76. And yeah, there's the smoke trail getting drawn in into a little torus, which is probably 25% of the total disc area, because there's not much coming through in the actual center, and there's nothing coming through the outside of it. So yeah, I'd say you've got 25% of that thing's actually working. The rest of it is responsible. And I've got it connected physically, so hopefully you'll pick up the growling which it makes. With all that flat square-edged sheet metal chopping through the air and leaving the air behind it, and what seems to happen is that the leading edge on the first 10 or 15% of the blade is actually parallel to that sheet of cast machined aluminium there. And then the blade sort of does that. As you can see, there's the circumference. So it comes along and it virtually cuts off a thin little slice of air, and then gradually at the 1/3 radius mark in that thick bit, that's where the air is shoved backwards. It's fairly different but similar to the way an actual air screw works. This is more, it's a sheet metal auger working through air. It's cutting into the air like a bloody woodworker's drill. Cuts into the wood, it shaves off a little bit and throws it back behind it. It doesn't actually make much of an attempt with its leading edge to generate, you know, an airflow that'll go up that way and then have to follow the curve round. It just slices it off and throws it backwards, you know, whoomp, 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 back you go, mate, back you go. And of course, it's a whole lot easier to production engineer than that whole thing, which I don't know whether the magnets have halfway been overcooked or whether the Peltier device is halfway overcooked, but it's pretty slow to start, and I decided it was time to retire it. And then when this one arrived, claiming to turn that kind of a heat distribution from just a hot stove radiating, or rather to achieve that instead of that. Oh, okay, they do that. But basically the air gets cut off, and then back here at the end, that's where it gets scooped up and thrown backwards. You can see it in the shadow play on the still photograph in the studio. Okay, rotating clockwise, flat, straight leading edges, curved, kicked up trailing edges, all rounded and smooth in an attempt to be able to get a sheet metal pressed 90-degree edges production engineered air screw to be as near as damn as to swearing silent between 600 RPM and 1200 RPM, which is about how fast I think it's going, based on the fact that that spiral is only drawn across 180 degrees. And you can see 2.5 of them there. And you're watching by the illumination of a high efficiency neon light, which, as you can see, is flickering at 50 times per second because the inverter is making alternating current out of stored direct current from the batteries. So if you position your head just exactly quite bloody right, and gee, look at the irritation the charge couple device picked up with that close encounter with the neon light. Yeah, if you hold your head at just the right correct angle, what you got is a 50 flash per second strobe. One final trick. 63 degrees metal at the ceiling, 65 degrees the outside of the air-cooled flue, getting cooler as we come down. Any kind of a discontinuity tends to give you a raised temperature. So when we come down here to an old corrosion band, it's going to go up. Yep, look at that, see? We come back down to there, it drops again. That corrosion band is where once upon a time there must have been a metal strap on it. Then we come down here and we drop down to, yeah, 60 degrees odd. We come down below the level of the airflow, 150 degrees, 178, 198. Right? 70 degrees. 88, 90 degrees. So the airflow through that fan at 2 or 3 miles an hour, coming through that pathetic little bloody donut that's actually working, it's pulling enough air past the flue to cool the damn thing down from 150 degrees to 70 degrees, and then it goes back up to 90 degrees once it gets out of the airflow. And now, the obligatory teaser. The dupe cone cascade tray has been superseded by one which is transparent. This drops 2 smoke trails into a pair of buckets, which in theory each drop a smoke trail into a lower bucket, and the 2 lower buckets each drop a smoke trail into a collecting bucket which has 4 exit holes. So if God's willing, the Pope's agreeable, and there's absolutely 0 crosswind draft within the hut, and the smoke from the dupe cone comes out there, goes into there, divides into 2, cascades down again, and then recollects before dispersing. And as they say, small things amuse small minds, you see. And before I go, there's one more thing to show you. Because, as we all know, life is relative and observer-oriented, seen by your own eyes, lit by the lights of all your own experiences and learnings and understandings and happenings and things you've been taught, things you've learned to accept as being facts. All the stuff I've been saying about there being one little part of that fan that's just actually working hard can be visually demonstrated by looking at the reflection from that 50 cycle per second strobe light when it's coming from a single source and being captured by the aforementioned charge of the coupling device. It is my contention that what we see here as a reflected sine wave is the light bouncing off the curved trailing edge, which is higher up than the leading edge. And I don't know, but I reckon what we're seeing is this is the part of the disc which is working as hard as it possibly can. Coming in here, you're not actually generating as hard or as pronounced a low pressure zone. And once you get beyond here, the tips are really not working very hard at all. And yeah, you can actually see it, as well as the bloody strobe effect. That's the center of the low pressure zone behind the fan and the center of the high pressure zone downstream of the fan. And it blows through from there. Whereas once you're from here out, that's the area where this is sucking so hard behind the axis of rotation, or the plane of rotation, that from here on out, congratulations, the poor bloody thing's working against itself, going backwards. And that, because it's so far out at the tip and it's got the highest tip speed ratio, yeah, that might be soaking up 15 or 20% of the entire shaft output, and that's what makes that gently aggressive, powerful, silentish little. It's the strength of the vortexes, basically going backwards through there and turning around, and the whole thing's chopped up, and there's a shear force across the airflow there, and you've got a really high velocity and pressure gradient there, and then down here you've just got a blockage in the center, and that's why we got that corkscrew central effect. So yeah, woohoo! There's really good reasons why I have an entire playlist, and now as it slows down, the sine curve gets bigger. Isn't it great? There's reasons why I have a playlist for me mad scientist videos. Warbles on a lot to YouTube. Ciao. Oh yeah, epilepsy warning. Whoopsie.